Hello and welcome back to the course. Today we're talking about maximum likelihood. So we have this curve that's fitting our data. It's great, but how do we know that this is the best curve that can fit our data? Just like with linear regression, there could be multiple curves of this shape that could fit our data. So how do we find out which one is the best one? Well, we need to calculate the maximum likelihood. And the way it's done is by looking at each data point. So for example, we start here and finding out for the person of that age, what would have this curve that we're potentially considering, what prediction would have it made? So this specific curve, this specific logistic regression that we've modeled, it would have said that a person of that age has only a 3% chance of saying yes or taking up the offer. So it's a very low chance for this person or this person of this age to take up the offer. And then we would continue. So for the next point, what would have the logistic regression modeled? So we know that this person took up the offer. We know it's a yes because that's our input data. But what would have the logistic regression said if we didn't know that the person took up the offer? And the logistic regression, the point would be somewhere here on the curve, and that would be 54% chance. For this person, or for this data point, would be 92%. For this data point, 95%. For this data point, our logistic regression for that specific age, a person of that age, predicts 98%. So we've got all those numbers. Great. Now, just to avoid cluttering this image, we'll do the bottom points on a separate image. So for this point, the logistic regression predicts a 1% chance. For this point, for somebody of that age, the logistic regression predicts a 4% chance. For someone of that age, a 10% chance. For someone of that age, a 58% chance. And for someone of the age, a 96% chance. But remember, on the right side over here with the nose, the values that we've illustrated, 1%, 4%, 10%, 58%, and 96%, those are the probabilities of somebody saying yes, taking up the offer. So the probabilities of them saying no are 1 minus that value. So let's add that in there. So 1 minus each one of those values is the probability of them saying no. So for example, for the first point, it is actually a 99% chance. The logistic regression is predicting that someone that of that age, there's a 99% chance that they will say no to the offer. And now we need to calculate likelihood. Likelihood is calculated by simply multiplying all of these numbers. So on the blue side, we multiply these numbers. On the red side, we multiply these numbers. And we get our value for likelihood. And then the way to find the best fitting curve is to look through all possible sorts of curves. Of course, there's a more sophisticated process behind this, but in a nutshell, you compare what the likelihoods are of different curves. So let's say our logistic regression modeling process started with this curve and calculated the likelihood to be this value. Then it went on to the next curve and it calculated the likelihood to be this value. Then the next curve, the likelihood was this. And through this iterative process, it found the curve with a maximum likelihood. So this would be the maximum likelihood out of all the curves, and that means this is the best curve. And that's how maximum likelihood is calculated, and that's how the best fitting curve of logistic regression is found. I look forward to seeing you next time, and until then, enjoy machine learning.